Somewhere in the universe right now, a black hole is being born, one of the most powerful objects in existence, forming in a violent instant. But where do black holes actually come from? How is one made? The strange answer is that most black holes begin their lives as brilliant stars. To build a black hole, you first need a truly gigantic star. So let's follow the life and violent death of one, step by step. Our star is a monster, with at least 20 times the mass of our Sun. Deep in its core, it crushes hydrogen atoms together to make helium. This fusion releases enormous energy that pushes powerfully outward. That outward push fights against gravity, which is always trying to crush the star. For millions of years, these two forces stay in near-perfect balance. As long as the star has fuel to burn, it shines and stays stable. But a giant star burns through its fuel at a furious pace. It may live only a few million years, a blink in cosmic time. As the core runs low, the star starts fusing heavier and heavier elements. Helium becomes carbon, then oxygen, neon, and on toward heavier metals. Each new fuel burns faster than the last, in a desperate race against gravity. Layer by layer, the star builds toward a core of iron. And iron is where the star's luck finally runs out. Fusing iron does not release energy. Instead, it swallows energy. So the outward push that held up the star suddenly begins to fail. The iron core grows heavier and heavier, right up to a critical limit. That limit is about 1.4 times the mass of our Sun. Once the core passes it, nothing left inside can hold gravity back. The star has run out of ways to save itself. On the surface, it still looks like an ordinary bright star. But hidden at its heart, catastrophe is only seconds away. And when it comes, it happens almost faster than you can imagine. In less than a single second, the core collapses in on itself. A core larger than Earth is crushed to a ball just kilometers across. The infalling matter races inward at a huge fraction of the speed of light. Gravity crushes atoms so hard that electrons and protons are squeezed together. They form an unimaginably dense ball made almost entirely of neutrons. This material is so dense that a single spoonful would weigh billions of tons. The outer layers crash down onto this core and violently rebound. That rebound launches a colossal shockwave racing back up through the star. A flood of ghostly particles called neutrinos pours out, feeding the blast. And then the entire star tears itself apart. This is a supernova, one of the most powerful explosions in the cosmos. For a few weeks, it can shine brighter than an entire galaxy. It scatters newly forged elements across space, the seeds of future worlds. But the explosion is not the end of our story. It is really the beginning. Because at the very center, something is left behind. And now the star's fate splits down two very different paths. What that leftover core becomes depends entirely on its mass. If the core is not too heavy, it settles as a neutron star. An entire dead star squeezed into a ball the size of a city. But if the leftover core is heavier than about 2 or 3 suns, it cannot stop. Not even the crushing pressure of packed neutrons can resist gravity now. Now, the core keeps collapsing, smaller and smaller, with nothing left to halt it. It shrinks past every known limit toward a single, impossibly small point. And in that moment, a black hole is finally born. Gravity becomes so strong that it wraps a boundary around the collapse. This boundary is the event horizon, the point of no return. Cross it, and not even light is fast enough to ever escape. All the mass is crushed toward a single point we call the singularity. There, our known laws of physics simply stop making sense. Around the newborn black hole, leftover gas can swirl into a glowing disk. As this matter falls in, it heats up and blazes with light. Some black holes even fire enormous jets of energy out into space. The brilliant star is gone. In its place is a silent, invisible giant. A single star has transformed into a place where space and time break. But collapsing stars are not the only way to make a black hole. Sometimes, two dense neutron stars spiral together and merge. Their collision can create a brand new black hole in a flash of light and waves. We now detect these events as ripples in space itself, called gravitational waves. And at the heart of nearly every galaxy sits a supermassive black hole. These monsters hold millions or even billions of times the Sun's mass. Exactly how these giants grew so big, so early, is still a mystery. From dying stars to merging cities of neutrons, black holes are born in many ways. Everyone is the ghost of something that once burned bright. The death of a great star is the birth of one of the universe's greatest wonders. And we are only beginning to understand how these dark giants come to be. If you love the wonders of space, subscribe and keep exploring with us. Thanks for watching, and keep looking up.